Hey guys, Mr. Ground here, and this is 8.3, adding and subtracting rational expressions. In this video, we're actually not adding or subtracting, we are simplifying complex fractions. So, what is a complex fraction? A complex fraction is a fraction that is made of fractions. So there's a fraction in the numerator, a fraction in the denominator, that kind of thing. Fracception. We're going to solve this using keep, change, flip, or multiplying by the reciprocal. So, a couple of quick examples. How would I do this? Now, sometimes I like to go ahead and darken and make that middle fraction bar a little bit bigger. Remember that fractions are, it's the same thing as a division symbol, right? So that's why we can use the dividing fractions method here, where we call it keep, change, flip, or multiplying by the reciprocal. So if we do keep, change, flip, right, we're keeping the top one, so it's going to be 2/3. We're changing this from a division to a multiplication, and then we're flipping that fraction from 4/3 to 3/4. Now if I multiply this together, we could actually cross cancel here, cross out the 3's, and it's going to be 2/4. We could also multiply them and then reduce it. So if I do 2 times 3, that's equal to 6. 3 times 4 is equal to 12. And then I just have to reduce my fractions. 6/12. Both of them are divisible by 6. It reduces to 1/2. All right. This one's a little bit nastier looking, but I promise this is actually probably easier than this one, because there's not really any reducing of the fractions. So we'll keep the top one, x minus 2 over x plus 3. Then we will multiply by the reciprocal of this one. So that's where the keep, change, flip comes in. So that one will now be x plus 3 over x minus 9. Well, now I've got a matching factor on top and bottom. Kind of like this one. I could have just canceled out the 3's, and I'd be left with 2/4. Which would have reduced to 1/2. Here I can get rid of the x plus 3's, and what I have left, x minus 2 over x minus 9. All right, here's a few examples if you want to pause and try them out. One of them is a little bit more of a challenge because there's some factoring that can be done with that one, but give it a shot and unpause when you are ready. Okay, so this one, we will keep the top as x plus 3 over x. We will flip the bottom one, multiply by its reciprocal. That's going to be 7x over x plus 4. Now, what is common on the top and bottom that cancels? The x's cancel. And what I have left, 7 times x plus 3 for my numerator, and x plus 4 for my denominator. This one, now if we do keep, change, flip, or if we multiply by the reciprocal, that x plus 1 over, this is a difference of squares, so I'm going to factor it to x plus 1, x minus 1. Then we will multiply by the reciprocal here, so we'll flip that, x minus 1 over x. And now what cancels out? X plus 1 cancels this x plus 1, x minus 1 cancels this x minus 1. Remember, if everything cancels in the top of a fraction, the denominator, that denominator is 1. So this is going to be 1 over x. And our last one, I'm going to write that one kind of up here. So it's going that way. Our top fraction is 20 over x minus 1. We'll multiply by the reciprocal down here. This 3x minus 3 is factorable. There's a GCF there, so I'm going to make it 3 times x minus 1. And then the 6, that's the denominator now. Okay, x minus 1's cancel out, and what I have left is 20 times 3, which is 60 over 6, and 60 divided by 6 is 10.